In today's video, we're going to continue with looking at parallel lines and angle pairs, but we're going to start looking at actually proving whether or not our lines are parallel. We can also do these problems where we're solving for expressions that are labeling parallel line angle pairs and approaching these kind of like we did with our angle pair problems in Unit 2. So there are two ways that we could have these problems written out. So some problems may say if parallel lines are given, then solve for x or solve for a missing angle on the diagram. Or we could say we're given these two angles, what would we have to have as a value of x that would prove these lines parallel? So we're kind of reversing the possible ways that those questions could be asking or could be asked. And so if we think back to our very first unit when we were talking about logic, when we reverse the statements like that, we're actually looking at the converse. And so sometimes you might see that reasoning listed as, hey, apply the converse of this parallel line definition or theorem. So the two ways that we could have these problems listed out is if we're given two parallel lines that are cut by a transversal and they give us corresponding angles, we know they have to be congruent. So if we reverse that, if we do our converse statement, we could say if corresponding angles made by a transversal are congruent, well, then that proves that the lines are parallel. We can do this with our other relationships that we studied during our first parallel line lesson as well. So alternate interior or alternate exterior angles, again, if we already know the lines are parallel, then we know those pairs also have to be congruent. So we can basically say the same thing, just using the new name. So if alternate, either interior or exterior, both pairs have the same property. Either pair, if those angles made by a transversal are congruent, then the lines themselves are parallel. It proves that they are parallel. And then our last one is if we have consecutive interior or exterior angles. So again, consecutive meant they were on that same side of the transversal. So if one's acute and one's obtuse, there's no way they can be congruent. So our other pair of angles or other property that we had was that the angles were supplementary. So if consecutive, and again, it's either interior or exterior, both have the same property. If those angles made by a transversal are supplementary, let's spell that correctly, shall we? Supplementary. Then the lines are going to be parallel. So this really doesn't change what we think about when we see these angle pairs. We still know that corresponding angles are supposed to be congruent. Alternate interior or exterior are supposed to be congruent. Consecutive or same side, interior or exterior, again, supposed to be supplementary. It's just the wording of the problems that might change up. So let's see some examples. So first example, in example 1, find the value of angle x. Well, if I look at where those angles are, let me switch back to red because it pops a little better on the diagram. I have two obtuse angles. So if I know that my lines are parallel, and it does say in the examples given that line L and line M are parallel to each other, well, then I know these angles have to be congruent, but the reason is because they're alternate exterior angles. And you want to make sure you know why your angles are congruent or why your angles are supplementary. Well, if they're congruent, though, another word for congruent is just equal. So we can just set our expressions equal and solve for x. So 16x plus 22 equals 134. Subtract your 22, so 16x is going to equal 112, I believe. And then divide both sides by 16. So 112 divided by 16 gives me x equals 7, lucky number 7. Alrighty, number 2, we saw this a little bit with our angle problems. We have x's and we have y's. So we have two different steps to solving on this one. And absolutely, when I'm looking at this problem, I know I'm not going to be able to combine x's and y's right straight out in the same problem and be able to solve it. So let's concentrate on our X labeled angles, which we've got one on the top, one on the bottom, but they're both on the left-hand side. So what kind of angle pair do they make? These are consecutive interior angles. So that means that these are going to be supplementary. In other words, this is one of those part plus part equals whole problems, and the whole is 180 degrees. So let's plug that in. So 5x plus 3 plus 9x minus 33 equals 180. Combine your like terms. So 5x plus 9x is 14x. Positive 3 minus 33 gives us a negative 30. Okay, add your 30 to both sides. So that gives us 210. And then divide both sides by 14, which gives us x equals 15. But the problem was asking us to find the measure of y. So what else would we need to know? Y is labeling an entire angle. So what if we knew one of the other angles? Well, let's go ahead and plug into this 5x plus 3. Why do you think I'm picking that one? Well, 5x plus 3 is adjacent to angle y. And actually, if I add those together, those would make 180. Is there another way that I might be able to do this that would be a little bit more straightforward? What about the 9x minus 33? He's actually the alternate interior angle with y. So actually, that's probably the better one to use. I could use either one as long as I set it up correctly. So I'm going to say that 9x minus 33 equals y. But now I know that x equals 15, so I can substitute that in. So 9 times 15 minus 33 is going to give me my measure for angle y. 9 times 15 is 135. And 135 minus 33 is going to give me a 102. And go back and double check your diagram. So that means 102 degrees. It's an obtuse angle, so it's bigger than a right angle. Does that look appropriate for your diagram? Awesome. So same kind of thing with number 3. We have two sets of variables. This one actually wants us to solve for both x and y. So again, let's just attack one at a time. So I have two expressions here that have x's on them. And again, not a bad idea to kind of highlight those angles or trace around them to bring your attention. What kind of angle pair are my x's? So those expressions are alternate interior angles, which means I can set those expressions equal. So 8x minus 31 equals 6x plus 3. Subtract your 6x from both sides gives us a 2x minus 31 equals a positive 3 or just a 3. Again, my suggestion is don't try to do too many steps at one time. Again, fairly straightforward math, but if you're trying to do a whole bunch of things all at one go, it's really easy to accidentally leave off or use the wrong sign. Okay, add a 31 to both sides would give me 2x equals 34. And then divide both sides by 2, x gives me 17. And so I'm going to have to do a similar thing to what we just did in the last problem. Our y angle, again, I'm going to have to do something either with setting it equal or adding it up with another angle. Neither one of these is in the alternate interior angle with our 5y plus 35. So I'm going to have to add up to 180. So I'm just going to go ahead and do that with these top two angles. It's a little easier to see in the diagram, but it really doesn't matter which one. So we would want to do 8x minus 31 plus 5x or 5y plus 35 equals 180. Again, this would work if I did it with the 6x plus 3 as well. And you're more than welcome to go through, check it, see if your number matches mine or your final solution for y matches mine. See, x equals 17, so let's substitute that in. Multiply out that value, so 8 times 17 gives me a 136. And again, notice, again, I'm not skipping steps on this one. I want to make sure I don't forget anything, don't miss any signs. Again, that's a 3. So then combine our like terms. We've got a 136, a negative 31, and a positive 35. I do not trust my mental math on that many values. So checking on the calculator, I get 140 plus 5y equals 180. And our numbers are starting to come out pretty nice. Subtract 140 from both sides. That gives us 40. Divide both sides by a 5, and then we're going to get an 8. Right. Awesome. Again, you can always plug your numbers back into check if you're unsure if your answer is correct. Alrighty, so let me save that. Next practice problem, same kind of thing, but our diagrams look spread out. So we have that we're still trying to solve for x and y, and we have two pairs of parallel lines here now. So the trick with this one is we want to make sure that when we match things up, we're kind of doing so along parallel lines. So we have the one pair, L and M. We have our other pair, J and K. And it would really help me to have all of my angles kind of around the same intersection to help out. So I know that I could actually move 11x minus 25 up to this top right angle using my corresponding angles. And then I could do corresponding angles again, just moving across the red parallel lines, and 11x minus 25 in this angle here. And so now I actually have all of my angles around the same intersection, and it just makes my life a little easier. And you don't have to do that, but that's our justification for why we can set this up this way. So we now have 11x minus 25 directly across from the 8x minus 1, which means what kind of angle pair did I make? Going back to unit 2, those are vertical angles, so I can actually set those equal to each other. So 8x minus 1 equals 11x minus 25. And I can solve that for x. So I subtract an 8x from both sides. Again, I could do this in the other order, but I tend to like to have a positive x value when I can. Add 25 to both sides, so that'll give me a 24 equals 3x. And then dividing both sides by 3, x equals 8. Okay, so our second piece. Again, I have to solve for the y, and the only thing with a y in it was this 15y minus 48. But what would happen if I combine that with one of the x expressions right next to it? They make a perfect linear pair, so that means they have to add up to 180. So I can do 15y minus 48 plus 11x minus 25 equals 180. And again, I don't have to do this pair. I could have used the 8x minus 1 instead. Both ways will work. Okay, plug in my 8. And again, I always like to plug that in before I do any simplifying. So that'll give me an 88 to work with. And now I can start simplifying my like terms. I have a negative 48, positive 88, negative 25. And again, if you're one of those that has a graphing calculator at home, make sure you're using the negative button and not the subtraction button in front of that 48 on one of those TI calculators. That comes out to 15 plus, or 15y plus 15. Okay, subtract your 15 from both sides. Give us a 165, I believe. And then divide both sides by 15. And we get y equals 11. Again, just in case you don't have a nice calculator to use with the test, again, don't forget anything that you have need of a calculator will either turn on the scientific calculator that you can use through your test online, or we'll actually embed a Desmos calculator if it's one of those problems that seeing the graph might help with that. Okay, so the rest of these problems, they're actually the same thing. So 3 more examples. But the idea is these are working the other way around. So the way the problem is worded is find x so that A is parallel to B. So technically we want to solve out for the x that would make those lines parallel, but we can approach the math the same way. So looking at example 5, again, it looks like 74 degrees and 9x plus 11 should be corresponding angles, which means what property should they have? Well, they should be congruent. So if we set them congruent and solve for x, well, that would prove that the lines are parallel. So let's do that. So 9x plus 11 equals 74. Subtract a 74 from both sides, so that's going to give me a 63. And divide both sides by 9, and we get x equals 7 again, correct? Divided by 9. Yep. So we have our answer, x equals 7, but we have to state the converse used. So the converse was, if corresponding are congruent, then the lines are parallel. And I know you don't have a whole lot of room, that's why I abbreviated on there. So let's do the same thing with number 6. So a few different angle pairs that we could use on this one, to be honest. But let's say, well, we have this 4x minus 18 and we have this right angle here. They're both on the same side inside the parallel lines. So what should be their property? No, they're consecutive interior angles, so they should add up to 180. So let's see what our x would be to make that happen. So again, I'm actually going to go against what I've done in previous problems because I see that I have a 90 and a 180, and I know that those go together very nicely. So I'm going to go ahead and subtract a 90 from both sides. And I'm going to pause here for a second. So wait a second, 4x minus 18 was equal to 90 degrees, but the other angle was equal to 90 degrees. This is something that you might see as a corollary. If you have two lines, so lines A and B, both perpendicular to the same transversal, aka this guy here, then the lines themselves are also going to be parallel. So it's something that you might see used in some proofs that we're going to talk about in a future video. But you can still use all the same rules that we've known before. So we can still do our work the same way. So let's go ahead and add 18 to both sides. So that's going to give me a 108. And then divide both sides by 4. We get x equals 27. So the converse technically that we used, if consecutive interior angles add to 180 or are supplementary, but that's not going to fit, then lines are parallel. Okay, so number 7, last example, a little bit of a challenge problem. So you probably won't see anything this tricky on the test, but we have all the info we need to solve it out. So let's see what we have going on. So again, use the problem itself as a hint. If we're trying to find x and y, that means, well, we can't use both of them. So looking at your x's first, what should we be able to do with those? And again, if you can't really see what's going on, try covering up the rest of the diagram. So we did that before. So let's do that. Let me cover up kind of the right-hand piece of this diagram. So if I'm only looking at the x expressions, one's on the left, one's on the right, but they're still in between the lines that we're trying to prove parallel, L and M, what kind of pair of angles should they be? Those should be alternate interior angles, even though they're kind of spread out a little bit differently. So alternate interior angles we know are supposed to be congruent. So let's set those equal. So 5x minus 38 equals 3x minus 4. Subtract your 3x. Add your 38. So 2x equals positive 34. Divide by 2 and we get x equals 17. But they wanted us to find y as well. So let's think about this. So the only expression with y is the 7y minus 20. I'm going to do the same thing I just did before. Let's cover up kind of the right-hand part of the diagram now. Well, let's see here. I have a few angles going on, but if I knew what this entire bottom piece was, oops, excuse me, let me undo that. If I knew what this entire bottom piece was, then which of those two blue angles, how are they related? Well, yeah, they're consecutive interior angles, the whole thing, so they should add up to 180. So there's nothing wrong with saying, well, why don't I just add the two pieces together from the bottom? So let's do that. Okay, let me go ahead and delete this piece here. There we go. And change my color back to blue. So that's what I'm going to do. I'm just going to add everything together. So I should be able to do 7y minus 20 plus my right angle to 90 degrees plus my 3x minus 4. And that whole thing comes together to give us 180 degrees. So here we go. Let's combine our like terms. Oops, before we do that, what should we do with our x? Yeah, substitute them in. So 7y. See, I don't know why it's showing that window. My apologies if that's covering something up, but I don't know why. Let me try. There we go. Okay. So then plug in your 17. So 3 times 17. Simplify that out so we can make sure we have all values that we can combine. So that comes out to a 51. And so I have several constants now that I have to combine, like terms. Again, use the negative sign rather than minus sign to start out with that negative 50 if you're using one of the TI calculators. Plus 90 plus 51 minus 4 all comes out to a positive 117. So now subtract your 117 from both sides. Gives us a 63, and so y equals 9. So if we had x equals 17 and we had y equals 9, that would be enough to prove that my lines are parallel. Alrighty, again, number 7, definitely a challenge problem, so please don't expect one that hard on the test. But if you understood what was going on with this, you can attack any of these problems. As always, let me know if you have any questions.